why they used heated air. So that was a way to heat up the heat to a certain level. Their thesis was that they want to use thermophiles, which are even more, they use a higher temperature level than the ones that we're looking at. And to do that, they needed extra air, hot air, to go in to raise it up to that level. So the idea is that bacteria is present naturally. If we tailor the conditions, we can get the bacteria that we want to get out of the whole mold. So the way one company did it was to use hot air instead of regular air. But even within the heat, with all the bacterial activity, it kind of maintains. It's almost like one set of bacteria does its reaction and it pushes the temperature all the way up to 60. Now it triggers the next
60 degrees C?
Of Fahrenheit.
60 degrees Fahrenheit.
Yeah. So then the next set of bacteria would catch on from that temperature level and start working. So the problem is that we're still working with the genetic side of it, and there's a little bit of genetic engineering involved that is now being proposed. Can we start making the bacteria, put it in there, instead of waiting on nature? But then we're talking about a lot of money involved. This was naturally working, and it's been working for years. They finally discovered it back in the 1950s.
In your columns, what were the columns made of? And was there any concern that the column material may affect the bacteria growth?
The actual material the column was made of? No, as far as I know, they are inert to the whole process, since they look like just porcelain structures. They weren't supposed to react with any of the actual ore material, because inside we're just talking about chalcopyrite, which is a copper ore in dirt, and with sulfuric acid coming down it. So as long as none of the material was reacting, I'm not sure exactly what material they used to make it, but it looked like a porcelain structure, and that's what they used to simulate the heat.
Thought was if it's some exotic alloy that leached out.
Oh, they would have definitely mentioned
metal
that.
ions you don't want might be affecting the bacteria.
Yeah, I don't think it would. I think they, I'm not sure what exactly the material was, but I'm pretty sure it's something that wouldn't affect the bacteria. They did do their work on that.
In the process for in the beginning, do you guys have a lot of corrosion problems?
From the heap itself.
Yeah, well, I mean, I guess you kind of expect that.
You do, and there is a lot of regulations, EPA regulations, in terms of leaching. They do have to line it with a certain material, and they do have to check it every 6 months, I believe, to make sure that it is working. And they do a good job. Mainly, you could attribute it to the concern of EPA fines, but at the end of the day, they do a good job about checking it day to day and making sure the sealing is working properly. And even places where they collect sulfuric acid, especially down here where they have a raffinate plant, where it's basically an open system of sulfuric acid coming in and leaving out, they recently got in trouble because some birds flew in and died, and you can't have that on a mine. So now they spent a lot of money and got these electric scarecrow machines that look like little eagles that starts clucking and start flapping its wings just to scare them away.
Yeah.
But they had to do it. They have to keep that in mind. So.
Well, also the water, getting into the water table, all that sulfur.
Yeah, that's where the protective cover that they use. They have to use layers just to make sure that it doesn't even touch the water table. Because they don't have a lot of population around the mine, but there's still a lot. The mine that I worked for, the city had about 20,000 people, so it could easily get in there. So the layer that they use, they definitely make sure that it's sealed off and doesn't leak. Because if it did, they would definitely be in trouble.
Did you say how much improvement the bacteria added to the process? If there were no bacteria, how much would the...
In our test, that we could just look at the control, but if we're looking at the overall heat, it would be hard to tell because it was a naturally occurring process. But within my sample, the only way to check it, would be on those two sets of graphs, and they showed bacterial activity within to naturally form. Those are the 4 tests where we added bacteria ourselves, but then over here, it seemed like it was still working based on the raffinate coming in. So it is a naturally occurring process, unless we do a step to eliminate that bacteria. So we didn't run a test to take out all the bacteria, we just ran a test where we added bacteria to the mix. Does that answer it?
Yeah, that was just for personal interest.
No more question? Thank you, Jibin. Why don't you step outside along with Rebecca and close the door, and we'll come get you in a bit.